EE World, I'm Martin Rowe. We're here in Washington, D.C. at the International Microwave Symposium. This is the Analog Devices booth, and Mosley Udine is going to give us a demo where it says here 6G FR3 spectrum analysis. Now, FR3 is a thing that the telecom industry, for the people who think that they're going to be able to get the spectrum between about 7 gigahertz and 24 gigahertz.
Something like that.
Nobody actually has it yet, but everybody thinks that the telecom industry is somehow going to either get it or share it. We don't quite know. But at any rate, the industry has to be ready for it, especially when you're down at the component level. So
Yes.
Mosley, why don't you explain what you've got going here?
Yeah, thanks, Martin. I guess what Martin said is that it's not here yet, but it's emerging, it's coming. And so ideally when it comes, we need to have instrumentation and we need to be able to test key aspects and certain things about it. And so what we have here is a spectrum analysis system. What we're showing is our newest Apollo MXFE, and it's integrated with our FR3 board. This FR3 board goes from 6 to 18 gigahertz. And what's happening is basically we're utilizing the DAC and ADC of the Apollo MXFE. The DAC can go all the way up to 20 gigahertz. We're sweeping the NCO frequency on the DAC from 7 to 16 just to show the capabilities of the FR3 board. And we're also using the ADC. The ADC has instantaneous bandwidth up to 10 gigahertz, but we're only utilizing at a fixed IF, so we don't need that kind of bandwidth for this application. What's happening is that we're loading a vector using on the DAC. We're loading the AX 80 megahertz bandwidth. If you span over here on the laptop, you'll see like this is an 80 megahertz bandwidth, and this is the AX Wi-Fi standard waveform. So what we're loading that, we're transmitting it out of the DAC into the RF inputs of the FR3 board. And then on this side over here, we actually have the 4382. We're using this as the LO for this FR3 board as well. So this actually connects right here. This is the LO. So with the RF and LO, they're getting mixed down, and we're keeping it at a stable 1 gigahertz IF. And that 1 gigahertz IF is being fed into the ADC on the Apollo MXFE board. So if you span over to that capture over here, this is the ADC capture from the Apollo MXFE. And you'll notice on the top right-hand side, you'll see that the frequency on the DAC and the frequency of the LO is always sweeping. So it's sweeping at 500 megahertz steps, but it's always keeping that 1 gigahertz IF. And you'll notice on the capture, you have it centered at exactly 1 gigahertz. And you'll notice the SNR of the waveform is pretty steady, even at higher frequencies. And it really shows the spectrum analysis capabilities of the whole system.